4, 3, 2, and 1. So at this time, all distractions need to be put away. Oh, but the screen on the board is frozen now. You never get through the day without some type of technical issue. Am I right? SPF, KBV. Okay, we're good, and it's alive. Nice. Alrighty. So can someone please tell me the first question of the bell work? 2x plus 3 is equal to?
5x.
Minus 8?
Yup.
Alrighty, and then what about the second one? 2/3 x
Plus 5 equals 11.
plus 5 equals 11. Alright, so let's go ahead and solve our first question. So Bella asked me a good question at the beginning. She said, which side do we go to? Okay. The side that we pick, in the end, doesn't really matter as long as we do the correct steps. So the way I usually like to decide which side we put our variables on is which term has the highest coefficient. So I'm looking at, I see a 2x and a 5x. 5 is greater than 2. So I'm going to do 5x, and I'm going to make my right side my x's. That means I'm going to make my left side my whole numbers, or the numbers without any terms. Okay, so on this right side, I want only x's. I have a 5x that's going to stay, but this minus 8 needs to be moved. How do I move this minus 8 to the opposite side of the equation? You say, what, sorry? Add it, right? Adding 8 is the opposite of subtracting 8, so we're going to add 8 to both sides, keeping the equation balanced. Okay, do you follow along, sir?
Yeah.
Appreciate that. Okay, so we're going to have 2x, then we have 3 plus 8, that's equal to 11. And then on the right side, we will have our 5x, and negative 8 plus 8 is going to give us 0. So I don't really have to put anything else after that. If you would like to put a plus 0, that's perfectly fine as well. You can go ahead and put a plus 0, but it is not needed. Okay, so I have my x's by themselves on the right, but on the left, I need just numbers. 11 is just a number, but 2x has the variable x in it. So we need to move 2x to the other side. Since it's a positive 2x, I'm going to do the opposite. So what's the opposite of positive 2x? Minus 2x, I heard some people whisper. So yes, we're going to be subtracting our 2x. Same idea of balancing our equation. So what we do on one side, we're going to do on the other. 2x minus 2x is 0. Bring down the 11. 5x minus 2x is 3x. And we can bring down the 0 or leave it off. So we are left with 11 is equal to 3x. Okay, so there's two ways to write that. 3x is equal to 11, or 11 is equal to 3x. Both ways are true. I want to get a single x by itself. Let me zoom in. Sorry, I did get a little bit small. Right, I want to get my x to be by itself, but there are 3 of them being multiplied. So what's the opposite operation of multiplication? Division. What number am I going to divide to get a single x? So Keegan or Mariah, did you say 3?
I didn't say anything.
Oh, was it Addison? Sorry, Addison. My fault. So why are we dividing by 3, Addison?
Because it's the smallest number.
No.
No,
It's the x. It's the x.
Yeah.
It's the number in front of our x, right? And since we want the number in front of our x to be 1, dividing by the number itself will give us to that 1x. So when we divide by 3, means we divide everything by 3. 3 divided by 3 is a 1, so we have a single x is equal to 11 over 3. Same thing over here, 11 over 3 is equal to a single x. So here is our answer for our first bell work question. Yes, Kaden.
I am so much smarter now.
Do you want it in decimal or?
So this one, since it's not, is it a rational decimal or does it keep going on forever? Keeps going on forever, right? So we're gonna keep this one in fraction. If you were to do it in decimal though, I would need you to round of some type. But this would round to what, like 3.67, right?
There's also a short.
You're the only one.
Just subtract 5 and get negative 3 plus 3 plus negative 8. And then
Can you pick that
subtract
up,
3
please?
and then you get.
You're getting
And then
water
subtract
off my
3
paper.
and then you would get the same thing.
But there would be negatives, right, instead of positives. So you had negative 11, negative 3x, right? But you still got the same answer in the end, right? So what the difference between what Quincy and I did, right? Oh, hey y'all, I'm still trying to explain our bell work. So the difference between what Quincy and I did was I put my x's on the right, Quincy put his x's on the left. Oh, we ended up with the same answer though, correct, Quincy? Of 11 over 3 or 3.67. Alrighty, any questions over this first bell work question? Any steps that need to be explained any further?
I wouldn't say so.
Alrighty, let's go to our second bell work question, which has a little bit of fraction operations embedded, right? We did those last week, so we got this one. Okay, so again, I need to pick my x's side and my number side. I see that my left side already has an x, so I'm going to pick that as my x side, and I'm going to make my right side as my numbers. So since my left side needs to be only x's, I have a plus 5 that I need to get rid of. How do I get rid of a positive 5?
Subtract it.
Doing the opposite on both sides. So I will have 2/3 x is equal to 11 minus 5. 11 minus 5 is equal to 6. So we have 2/3 of x is equal to 6.
That's where I got stuck.
So we have two options to go from here. We can either divide by the same fraction, 2/3, or we can undo the fraction, 2/3. Which one do you guys want to do? You guys want to undo the fraction or divide by the fraction? Okay, Quincy said undo. Anybody else? Undo, undo. Alrighty, so let's undo the fraction. Undo the fraction. When we undo a fraction, we have to do the opposite of what the fraction is telling us. So this fraction tells us 2 over 3,
3 over 2.
right? That's the reciprocal. We don't need that for right now, but eventually we will in a second. Okay, so right here, this dividing by 3. What's the opposite of dividing by 3? Multiplying. So let's go ahead and multiply both sides by 3. So we will get 3 times 2 divided by 3, x, is equal to 6 times 3. What's 6 times 3 equal to? 18.
Hey, Mr. Marbot, I'm missing my bell work. Like, this is the bell work, but I didn't turn it in.
Okay, so you can turn it in later after this, okay? Just make sure you have the correct week on top of there.
What week is it?
This is the 21st. No, 27th. Week of 27th. Alrighty. So we have 3 times 2 divided by 3. Well, what is 3 divided by 3 equal to? It's equal to 1. So we can simplify 3 over 3 to 1 over 1. And we will now have 1 times 2 over 1 times our x is equal to 18. Okay, there's an arrow to our next step. 1 divided by 1 is still 1, so we can actually just simplify this once again to 2 times x is equal to 18. So we want to get a single x. There's 2 of them being multiplied by our x. So what's the opposite of multiplying by 2?
Divide.
So let's divide
Equals 9.
by our 2. 2 divided by 2 simplifies to 1 over 1, which is 1. 18 divided by 2 is equal to 9 over 1. So that tells us that you guys can't see that, sorry. That 1x is equal to 9 over 1. Or what does that simplify furthest into? To just 9. So our x for our bottom is equal to 9. Okay, the other way we could have done this is through keep, change, flip, where we divided by just the fraction. So I am going to show that way just so we know, but we will get the exact same answer, right? So 2/3 x is equal to 6. Divide by 2/3, divide by 2/3. So we will have 1x is equal to 6 divided by 2/3. We can do our keep, change, flip, and we get that our x is equal to 6 times 3/2, right, Kaden? Like
Yeah.
as you're saying, 3/2 that we're looking for. Make the 6 into a fraction, multiply straight across, and we will get 18/2, which simplifies to 9/1, which is just 9. So 2 ways to do it. We get the same answer both ways. Okay, and that is our answer to our bell works. Okay, please make sure your bell work has all of this plus your work that you did to get to the end. Once you have that, please open up your textbook to page 351. Okay, 351. It's going to be right here at the top. Page 351. Okay, I'm going to hand out some materials. While you guys get your book open to the correct page.
Can I have colors? What?
Really want me.
That's it.
Yeah.
Keegan, you want to help me pass on some stuff?
Sure.
Yeah,
I guess I will.
Kevin or me?
Everyone?
Kevin or me?
You're Evan.
LeBron James, Zach Wilson. There you go.
One. Two. One.
Good boy.
Don't call me a good boy.
let's not say that. That's one of the bad things in this classroom that I don't appreciate when you say that.
Thank you, Keegan. You want one, Mr. Marble?
I have my own. Thank you, Keegan.
Okay.
Appreciate that.
What is for you?
You know what, Keegan? You are a fine artist.
Thank you. Is that real? What is that?
They give me card six. We'll get your card for eventually. They're passing around. They're getting passed around.
Why is it all saying you're welcome?
Already got it.
Thank you. You have food? I don't think so.
Alrighty, so with the cards that were passed out, can you guys please make sure you have card 1 through card 6? Okay, you should have 6 cards.
3, 4, 5, 6. Yeah, I got 6.
Can you make sure you have card 1 through card 6 for me in your pile over here? And then could you also appreciate that, sir. Guys, if you guys have help me, that like where it needs to be. Remember page 251? So you guys have to get out. Do you guys have 1 through 6?
Yeah.
Yeah, 1 through 6 is okay then?
Yes, he does. There's 6.
Yeah. Alright.
I was.
Oh my gosh, that was like, ow.
Alright. If you have all 6 cards, or if you have card 1 through card 6, Go ahead and put them just in one pile and set them aside. We don't need them right at this moment, but we're going to need them here soon.
Evan, wake up. Evan. Thank you, fell asleep.
Okay, so what page should we be on actually? Okay. 351. So please turn your page to 351 for me, sir.
Okay, yeah.
Please turn to page 351 for me. Could you listen to Miss Thing? So she can right place at the right time. Is that one? You're not following along with us. I need you to either follow along here or follow along. 351, sir. Alrighty, everybody. Thank you guys for being patient with me. So, if we could please focus in the fronts with our voices off and all our devices put away. Dylan, sir, could you please put away your phone?
Yeah.
Okay. This is your first warning. If I have to ask again, I'm going to ask you to take it to the office. Thank you, sir. Alrighty. So, I am ready to start notes. I am waiting for you guys to be ready as well.
I'm ready.
Yes? You ready, Kaden?
Yeah.
Thanks, sir. Appreciate that.
I'm also ready.
Appreciate that.
Me too.
Alrighty. Seems like we're ready to go, so let's go ahead and go forward. Okay, so let's look at page 351. Okay. Our goal for today is to identify what similar figures we have and to see if we can connect similarity with our transformations that we've done before. Okay, so real quick before we start here, what are all the transformations that we have done today? Or not today, sorry, within our semester and a half here.
Dang, we've already done this semester.
Okay, so give me 1 second. Transformations. Okay, these are going to be our rigid transformations, and then we'll do our non-rigid over here.
Hey, Evan, I think you should pay attention.
Alrighty. So, what was the one you said, sir? A reflection. Reflection is one of our rigid transformations. Nice. Translation is another.
Rotation.
Yes, thank you, Keegan. Rotation. Oh, rotation. Okay, so reflection, translation, and rotation were our three rigid transformations. What was our one non-rigid transformation that we've been focused on these past week or so? Dilation. Okay, so we're going to be using these transformations here in a second. But let's go ahead and look at our warm-up to begin with. So, we have two figures here. And it says right here that there has been a dilation miscalculation. Okay, so what is wrong with this dilation? Why is quadrilateral GHFE not a dilation of ADCB? Okay, I'm going to give you about 30 seconds to think about your answer. While you think about it, please write it down in your book. Okay, so right here, why is this not a correct dilation? Okay, so I'll give you guys a few seconds. Think about your answer. Okay, once you have it in your head, go ahead and write it in your book. Why do you think this is not a correct dilation?
Where did my pencil go? Oh, this is it.
Miss Diane. Okay. So I'm gonna go ahead and move your stuff over there. Okay. If you're not able to follow along at the table over there, I'm going to ask you to go to the office and you will be put over there. Okay, so you want to come over here and sit with me? Or sit with Mr. Diane?
How's it going? All right.
Please pay attention. You're back.
And so you're going to be sitting over there or what? Are you going to refuse to go that way? Alright, so I'm going to take your stuff and go to the office. If you're not going to be following along in class.
Please pay attention.
Here's your stuff. You want to go to the office?
Go ahead.
Can't follow along in class. Just someone follow yourself better.
Okay, I already gave you the chance, sir. I gave you the option and the chance to prove that you can't follow along. So,
Please, there's nothing I can do.
I'm not asking for any rationalization. I'm not asking for any excuses. I'm asking you to do the work. Simple as that. So if you're not doing the work, I'm asking you to leave my room. Okay, so I'm going to be calling the office, letting them know you're on your way to the front. Or you can go with Miss Diane and sit over there, which is you. Do you have anything you want to... Yes, ma'am. You want to make a pass for me? Evan, sir? Evan? Can you please go ahead and grab your stuff and go to the office, please? Alright, do you need me to get Adam to bring you out of the office? Okay, so you grab your stuff and go there. I will let the office. I'll let the office know you're on the way. Are you sure they are expecting you?
Be best friends with Hitler as a young kid.
I forgot. I stopped it.
Alrighty. Sorry about that, everybody. If we could please refocus. Okay, so I saw some good answers in your guys' book. Micah, could you care to share what you wrote down? Okay, so Micah said that the points. You guys ready for?
Yeah, sorry.
Okay, the points aren't on the line, right? We look at B and E, they aren't on the line, and if we were to extend the line from our B to our E, we would see, oh, sorry, that should go further out. Okay, hey Keegan, you should be focused on notes. Okay, if we were to extend, line PA, the dilation, point E should also be on that line. Point E is not. So that is a good observation, Micah. Anybody else? Keegan.
I said, because only the sides change distance, the tops do not. So
Right. Sides change, but top does not. Great way, right?
Oh, I did that too.
You had that too, Kaden? Awesome. Quincy, what did you... Oh, sorry.
What's the word after points? I should be right.
My fault. The points are not.
Oh.
Are not. The point, it was supposed to be aren't. Are not on the line. Quincy, what were you saying? Sorry about that.
Transformation of E isn't a square.
It's not a square, right? It changes the shape. And isn't the definition of dilation that the shape stays the same, but the size doesn't? Okay, so these are all good reasons as to why we do not have a correct dilation. Awesome job on that, guys. Okay, so we're starting to recognize when we should see dilations, when we have a wrong dilation, okay? So great job on that. Okay, so let's go ahead and turn our page. Okay, we should be on page 352. 352. Okay, so I already gave you guys your 6 cards, right? So we're going to be using those. So can you guys do me a favor? Get your 6 cards and hold them all in your hand. Okay? Okay? Please pick up all 6 of your cards in your hand now. Okay? So, if you look at all of your cards, there's similarities, there are differences. What I want you to do is I want you to put them in groups. Group them by what is the same
Someone drew something on that.
or by what is different. Keegan, did you hear what I said?
Yeah, but someone
Okay.
just drew
You're
something.
such a
Okay,
snitch.
Keegan, that's not important right now.
Sorry.
What's important is our content.
Yep.
Okay, thank you, sir. So, once again, please organize these 6 cards into any groups
Bless
you
you.
see fit. We're going to go ahead and talk about them in a little bit. Okay, so I'll give you about a minute to organize your thoughts and get your papers in the correct groups that you want. And then we will talk about them.
Or do they have to be in like groups?
Any group that you want, and you have to make sure to keep it in mind so you know what, so you can tell me why you put them in a group together. Okay?
You blow bubbles. I'm sorry, I forgot this one. Guess what?
What are we doing?
Huh?
Chicken butt.
Guess what?
What?
Chicken butt. What? Guess what?
That works out. They're in 2 different groups. Good job.
Oh, scream.
Alrighty, about 30 more seconds to get your thoughts organized. Okay? Oh, sorry, I forgot. So can you get your 6 cards? Okay, and we're going to turn your page in real quick. So right now, we're sorting the cards into categories of your choosing. Okay, so you choose how you want to organize them. Okay, put them in different groups. Let me know, and then I'm going to talk about how did you put them into groups. Okay?
Don't judge. You have Kaden all the time.
Kaden is my
What? Say that to him.
So Kaden's my best friend.
You said boyfriend.
No, I said best friend.
Addison, you get yours grouped?
Yeah.
Perfect. Keegan, you're getting yours grouped, sir?
Yeah, I'm just trying to figure out.
What you want to do?
Yeah.
Okay, okay. Do you need some more time, more than another 15 seconds?
Well, I'm just trying to figure out if this is a dilation
It's not.
or a rotation
Okay,
or
okay.
what it is.
Sounds good. I'll give you a couple more. I'll give you a couple more seconds. All right.
Can you look at mine?
I'll give you a few more seconds.
Can you look at mine?
Me?
I think that's in its own.
So these two.
It can.
How are they grouped like this?
What?
Oh, we're supposed to do it.
Nothing, Keegan.
And you need to calm down. Yeah, blood.
Okay. That's fine. What made you want to put these two together? They were the leftovers? Different from these two and different from these two? Okay. Sounds good. They're the outside
Okay.
ones, right? Sounds good. No. You were able to group them. How you soft.
Did I do good?
I'm happy to see yours yet, so we'll
Yeah.
talk about them.
Just say it.
Keegan, you got enough time, sir?
Yeah,
Got them grouped?
I think so. I
Alrighty.
don't know. I give up.
Proud of you.
It's okay. I'm sure you got a pretty good separation. Alrighty. So, can someone please share me what cards they had grouped together and why they grouped them
I had
together?
6 and 4 together.
Okay, so Keegan had cards 6 and 4 together, right? So everybody see their 6 and 4? It's on the board if you can't see them. Okay, so I'm gonna go here. We said card 4 and 6. This is for Keegan. Okay, 4 and 6. Why was your reason to have 4 and 6 together?
Because they're both rigid translations.
Okay, oh, there's rigid transformations,
Yes.
not translations,
Yeah.
transformations. Nice. Rigid.
Don't call me stupid. I didn't. I called you smart.
Okay. Keegan, your other groups?
And then I had 5, 3, 1, and 2 together.
Hey, can you pause for a second? Hey, Caden, sir. Keegan was trying to tell me something.
sorry.
Talking over him is not respectful. If you could please not do that. Appreciate that. What? One more time, Keegan.
5, 3, 2, and 1.
5, 3, 2, and 1. Okay, so he did card 1, card 3, card 5, and card 2. So the rest of your cards.
Yeah.
Okay, and what was the grouping of these ones?
They are not rigid transformations.
Nice. Not rigid transformations. Good. So non-rigid transformations. Okay. Can I get another person to share how they grouped it? Quincy.
I did 1, 6, and 5.
Did I spell your name right, Quincy? Q-U-I-E-N-C-E?
QUINC.
Ooh, N-C. There's no E right there? Okay. Sorry about that. Okay, sorry, one more time.
1, 6, and 5.
1, 6, and 5. And what was your reason for that? Nice. We have triangles. Nice. Awesome job. Hey, Keegan, Addison. Quincy's trying to share us. So if you guys could please not talk over him, that'd be greatly appreciated. Quincy, can you continue?
And then I did 2, 1, 3, 2, 3, and 4.
2, 3, and 4. And these were
Quadrilateral.
quadrilaterals. Nice. Nice. Quadrilaterals. This is an awesome way to separate them, right? Quadrilaterals versus triangles. Awesome job. Okay, let's do one more. Okay, can I get one more person how they group them? If anybody grouped them differently. Zoe?
1, 4, 6, and 2 are right angles.
1, 4, 6, and 2 have right angles? Nice. So there are right angles. Awesome job. Okay, and then the other ones?
Don't. Are not right angles.
So that would be 3, 5?
Yeah.
Those are the only two, right? Yeah. So 3 and 5, non-right angles. Awesome job, Zoe. Okay, so if you had something different from these 3 people, don't worry. Your way is probably still correct as well, right? There are many ways to separate them. Good job on seeing that we can put these into the different categories. I really liked every single one of these, right? I think my favorite, though, would have to be the rigid transformation versus the non-rigid transformation, just because that is what this lesson is over. Okay, so now, keeping with your cards, Keegan, are you?
Yeah,
You
I'm
good?
here.
Okay, keeping with your cards, I just want to make sure you're following along. Okay,
You okay, Keegan?
what I want you to do is don't write on the cards themselves. Please write on your paper. Tell me which card you're looking at and what transformations have to have been done. Okay, so I'm going to do card number 1. Okay, so nobody else can do card 1, all right? So everybody else has to pick a different card.
Dang it.
So for card 1, I'm seeing that this is a dilation centered at O. And I'm not seeing any reflections, rotations, or translations. So this is my only transformation I have. A dilation centered at O with a scale factor. What's the original, right? It goes from PON to QOR, I think. Yeah, from F to G. That's what it says now. So from F to G, this is a dilation. So this has to be less than 1, but still greater than 0. Okay, so that is my transformation for card 1. I have a dilation centered at 0. And since it was a dilation that got smaller, I know my scale factor is between 0 and 1. If I were to actually find it, it would be 7.5 over 5, which is equal to 15 over 10, which is equal to 3 halves. So my scale factor would be 3 halves for this. Oh, wait. Should be the other way. 2 halves. My fault. Should have been flipped. 7.5 on the bottom. All right, so it should be that. That should be our scale factor. Okay, so please find one card and tell me what transformations have had to happen. Okay, the rest of these, 2, 3, 4, 5, and 6, should have multiple transformations. Okay, what time is it? 6:107. Okay, so this will be our last piece of notes. Okay, so once you have all your transformations written down, please show me and I will let you know to go ahead and put your stuff away for the day. So let me know when you are ready for me to check.